The ideal compact weapon engineered for vehicle crews turned into a fatal liability in actual combat. During the First Chechen War, elite Spetznaz units faced severe casualties while armed with the AKS-74U. But the root of this design failure dates back decades before those urban ambushes, directly to the 1970s. Inside the heavy steel turret of a T-72 tank or the armored cockpit of a Mi-24 helicopter, operational space is strictly limited. The standard Soviet AK-74 rifle measured nearly 1 meter from muzzle to stock. Space was scarce. A long barrel would snag on sensitive optics or radio panels during an emergency exit. A fixed wooden stock would block narrow escape hatches. Vehicle crews simply could not swing a full-size infantry rifle within those rigid spatial dimensions. Due to these tight constraints, the military issued Makarov pistols to specialized troops. It changed nothing. A 9mm handgun offered zero stopping power beyond 30 meters. Helicopter pilots and logistics truck drivers were left heavily outgunned during rapid roadside ambushes. This created a massive logistical gap across the entire Soviet armed forces. Command had to choose between a heavy rifle that could not fit through an armor hatch or a light pistol that could not penetrate enemy cover. In 1973, military leadership formally drafted an order for an entirely new intermediate class of compact firearms. The 1973 project. Modern translated the frontline demand for compact firearms into strict technical specifications. Maximum weight stood at 2.2 kilograms. Total length capped at less than half a meter. Engineers demanded a muzzle velocity exceeding 700 meters per second. This created an immediate ballistic contradiction. Velocity requires internal barrel volume. They demanded lethal penetration at a distance of 500 meters from a barrel measuring barely 20 centimeters. Several Soviet design bureaus submitted competing prototypes, but the board favored manufacturing efficiency over ballistic perfection. Mikhail Kalashnikov secured the military contract by taking his existing AK-74 platform and executing a basic mechanical compromise. He retained the standard stamped steel receiver. Workers at the Izhmash plant chopped the barrel down to exactly 20 centimeters. The gas block shifted rearward. The sharp metallic clack of the folding stock locking into place signaled operational readiness. Folded, the weapon met the physical length requirement. However, the real mass exceeded strict limits at 2.7 kilograms. This shared receiver architecture dictated the production reality. Kalashnikov repurposed standard magazines, trigger groups, and internal trunnions directly from the full-sized infantry rifle. Utilizing the active assembly lines of the standard rifle saved millions of rubles from the Soviet defense budget. Retooling a weapons plant for an entirely new platform usually required years of downtime. This cut-down variant bypassed that bureaucratic delay. The military acquired an intermediate compact weapon without funding new tooling. The entire assembly process relied on existing infrastructure, removing the need to construct new production lines. A blast of expanding gases illuminates a dark room, instantly stripping the shooter of their night vision. This flash was the direct consequence of a compromise that disrupted the internal ballistics of the weapon. When engineers severed the barrel to 20 centimeters, the powder charge lacked the physical space to burn completely. Propellant gases escaped too quickly to cycle the internal mechanism. Designers relocated the gas block rearward, altering the established timing of the automated operating cycle. To guarantee reliable cycling, technicians installed a conical expansion chamber onto the muzzle. This steel device momentarily trapped the high-velocity gases, creating a delayed pressure spike that forced the piston backward. This technical compensation generated a tactical vulnerability for operators firing the weapon in low-light environments. Engineers mounted a tiny flip-up aperture sight directly onto the stamped receiver cover. This metal shield vibrates erratically under the heavy mass of the bolt carrier group. The rear sight featured fixed combat markings for engagements at 200 and 400 meters. Hitting targets at 400 meters with a short barrel proved physically improbable. The mechanical vibration of the receiver cover degraded the sight picture after every trigger pull. The testing committee classified the sighting mechanism as defective and demanded an urgent redesign. The testing committee rejected the defective sights, but the primary threat remained the physics of a shortened barrel during automatic fire. An infantryman clearing a corridor had to tap the trigger. He squeezed off 2 or 3 rounds at a time. It was the only way to prevent the metal from boiling over. The internal mechanics directly doomed the external ballistics. The shortened barrel forced the bullet to exit the rifling prematurely. Unburnt powder combusted entirely outside the muzzle. It wasted kinetic energy in an external fireball. Muzzle velocity plummeted from the standard 900 meters per second down to 735. The secondary failure mechanism was thermal breakdown. The gas system drove the action at a cyclic rate of 700 rounds per minute. A standard 30-round magazine emptied completely in less than 3 seconds. The sequence of failure was highly predictable. The shooter initiated sustained automatic fire. After just 60 to 80 shots, the steel barrel absorbed critical temperatures. The radiating heat of the steel barrel burned straight through standard-issue canvas gloves. Thermal expansion physically deformed the internal rifling. Bullets began to yaw and tumble randomly off their intended flight path. A standard infantry combat load of 210 rounds destroyed the barrel within minutes of a high-intensity firefight. The weapon stripped the 40th Army Infantry of crucial tactical options. The shortened front end completely prevented the installation of the standard GP-25 underbarrel grenade launcher. Soviet soldiers lost their primary tool for explosive suppression during mountain ambushes. The contrast in field application was stark. The perfect, compact weapon for transport drivers became a fatal trap for frontline assault groups. The actual effective engagement distance collapsed to between 50 and 100 meters by the start of the campaign in Afghanistan. A construction soldier of the 40th Army carried the lightweight rifle over his shoulder with minimal effort. But for an infantryman pinned down under mountain fire, Project Modern failed its first true combat test in 1981. Rear echelon units, pouring concrete, praised the compact carbine. For assault groups, the physics of a shortened barrel dictated the outcome of every prolonged firefight. Peak strength of the 40th Army exceeded 115,000 men. Standard infantry needed reliable rifles. Issuing this defective weapon to the front line caused a logistical failure. A soldier held the trigger down to suppress a ridgeline. Unburnt powder flooded the gas tube. The shortened barrel absorbed the rising heat. Within 60 seconds of continuous firing, the steel reached a critical temperature. The sharp smell of melting varnish from the wooden handguard signaled physical breakdown. Thermal expansion warped the barrel profile. Bullet trajectory destabilized, dropping accuracy to 0. The shortened gas block eliminated all space for underbarrel attachments. There was no mounting lug for the GP-25 grenade launcher. This deprived soldiers of their only tool to suppress elevated mountain positions. Firefights required heavy suppression, but the volume of fire needed to survive an ambush instantly cooked the weapon. A short carbine meant to protect transport crews erased any chance of winning a sustained engagement. Soon, Mujahideen fighters began extracting these exact rifles from the wreckage of downed helicopters. How does a fighter acquire a weapon missing from local black markets? Only by tearing it from a shattered Mi-24 attack helicopter, or the body of a dead Spetsnaz officer. A disastrous compromise for Soviet infantry instantly became the supreme status symbol for Mujahideen leadership. The AKS-74U was brand new and restricted. The Soviet command issued these carbines exclusively to high-ranking officers, special forces operators, and aviation crews. The Mi-24 Hind carried a crew of 3, and shooting one down required immense effort. Therefore, capturing this specific rifle served as undeniable physical proof of a high-value kill. It was not just a firearm, it was a verifiable scalp. Carrying the stark black metal against traditional Afghan garments projected immediate authority. Money could not purchase this level of respect. Only a dead Soviet crew provided it. A tall Saudi fighter named Osama bin Laden recognized this mechanism perfectly. He deliberately ensured cameras filmed him with the AKS-74U by his side during subsequent decades. He had access to any arsenal, yet he chose this specific carbine. It signaled a direct victory over a global superpower. The compact dimensions also allowed easy concealment for a target hunted worldwide. This specific operational context cemented the rifle's ideological value. Ultimately, the weapon secured a permanent designation among jihadist groups. The new nickname became the Osama. While militants used their own moniker for the rifles, the most famous Western designation was never spoken inside the Soviet Union. Russian operators focused on physical dimensions, labeling the compact system the Okorak. Western reporters embedded with Afghan fighters throughout the 1980s popularized the term Krinkov. Weapons researcher Patrick Sweeney conducted extensive archival searches, discovering that 0 Soviet officers with that surname were ever captured. The anomaly became so embedded in American firearms culture that United States manufacturers utilize the fabricated designation in official parts catalogs today. This international mythology remained completely disconnected from the tactical identity of the hardware. Operational realities dismantled these media fabrications during the subsequent urban deployment. Assault elements received their final coordinates on December 31, 1994. The media fabrications collided with solid concrete as 1994 ended. Special Forces operators moved up a pitch-black stairwell, preparing to empty a 30-round magazine on full auto. Ministry of Internal Affairs troops pushed into the presidential palace in Grozny. Soviet architects originally engineered this specific structure to withstand regional earthquakes. Thick, reinforced concrete floors absorbed structural stress from artillery fire. However, these same dense materials trapped every generated sound. Every echo stayed inside. The complex formed a rigid fortress for close-quarters combat. Capturing the location required 3 continuous weeks of room-to-room engagements against dug-in defenders. A short barrel dictates specific thermodynamics. 210 millimeters of rifling do not provide enough distance. The standard powder column could not burn entirely before the bullet exited. An operator squeezed the trigger in the dark corridor. Unburned propellant exited the muzzle device at high pressure and ignited in the surrounding oxygen. A bright fireball illuminated the enclosed stairwell. The intense flash temporarily blinded the shooter, degrading natural night vision. Simultaneously, the deafening acoustic shockwave slammed into the concrete walls and rebounded directly into the assault team. The confined geometry amplified the concussive blast. This physical signature turned the weapon into a glowing beacon. Chechen fighters, many holding extensive combat experience from the Soviet-Afghan conflict, simply waited in the darkness across the hallways. They watched for the sudden burst of light. Veteran snipers fired straight back into the exact epicenter of the flash. Across wide urban boulevards, the short-barreled carbine lacked the necessary terminal velocity to reach opposing firing positions. The specialized aviation survival tool directly compromised infantry survival rates during building clearances. These specific tactical casualties would soon force Russian military leadership to acknowledge the engineering mismatch. Orders came to withdraw the platform from primary assault units. The carbines left the front line entirely. The military command acknowledged the failure of infantry deployment. The carbine shifted exclusively to specialized police elements. An assault operator swings the short barrel through a narrow apartment doorway. The muzzle clears the wooden frame without a single snag. Production officially ended in 1993. That cutoff supposedly signaled a total phase-out of the weapon. Instead, elite counter-terror units demanded targeted modifications for close-quarters combat. Barrel length dictated survival in closed spaces. The standard infantry rifle featured a 415 mm barrel. The compact variant measured just 210 mm. That difference allowed a shooter to pivot instantly. Hallways in standard concrete panel buildings measured barely 1.2 meters wide. An operator slides a night vision optic onto the receiver rail. He aligns a steel suppressor with the muzzle threads. Metal grinds sharply against metal. The operator twists the heavy cylinder into place until it locks. By the start of the Second Chechen War in 1999, the regular army transitioned to the AK-105. That newer platform provided proper ballistic range. The original compact carbine migrated directly to the FSB, SOBR, Alpha, and Wimpel teams adopted the remaining inventory. For hostage rescues in confined spaces, the stubby weapon provided a definitive tactical advantage. The physical flaw of a severed barrel transformed into a primary engineering strength. Russian tactical teams locked the carbine into urban entry roles. Foreign smuggling networks diverted the weapon toward an entirely different global war zone. 6 fully loaded 30-round magazines sat beside a post-1986 production carbine. Iraqi forces cleared the underground cache in 2019. The short barrel that previously helped Russian units breach narrow apartment hallways now provided discreet vehicle concealment across the Middle East. Old exported Soviet batches reached the combat zones. During the Syrian civil war, black markets traded tens of thousands of firearms. Smugglers prioritized these compact dimensions over full-sized infantry rifles. This specific recovered hardware directly equipped 2 of the most wanted terrorist group leaders. The same hardware that fed Syrian supply lines never lost its trophy status further east. A Taliban commander walks through Kabul. The short sling pulls the weapon tight against his chest. He does not hold the grip. He has no intention of aiming. The bluing on the receiver edges is stripped down to bare metal. It emits a cold white metallic shine. In 1989, Soviet troops abandoned hundreds of armored vehicles and thousands of infantry rifles during their withdrawal. Yet this specific compact variant became the ultimate marker of high command. Engineers designed the AKS-74U for a completely different reality. It was a rear echelon tool, a compromise for artillerymen and tank crews. It solved the gap between a pistol lacking range and a full-sized rifle snagging in vehicle hatches. Mechanically, the system remained a flawed device. Short barrels meant extreme muzzle flash and severe ballistic degradation. Troops hated it. Decades later, the weapon mutated into a digital icon. Gamers used it to drop nuclear strikes in Black Ops, and James Bond seized one in GoldenEye. Millions recognized the silhouette. Few understood the actual ballistics. The original users considered the carbine a massive liability. They would have gladly exchanged it for a standard infantry rifle. But on the streets of the Afghan capital, ballistics no longer matter. A weapon taken from a defeated superpower carries more weight than any factory-fresh rifle. The Mujahideen claimed these trophies in the 1980s. They passed them down from fighter to fighter for decades. Today, the short carbine hangs over the shoulder of a Taliban commander in Kabul. It is an article of clothing. It is not a combat tool.